Hi girls, Mr. Gilmore here, just back with you on another simultaneous equations piece of work. Again, this work is going to be our second lesson on simultaneous equations. Again, this is just kind of a review of this material. You will have done it before. And today we're going to be looking at solving simultaneous equations with negative values and also how to rearrange simultaneous equations so that we can solve them, okay? So, the first thing to look at here is something along the lines of x plus y equals 5, but x minus y equals 1. Now, you'll remember in the last class, when we had these two terms, we were subtracting them, right? Now, in this situation, you'll notice that the y here is positive and the y here is negative. So we don't actually need to subtract them. We can actually just add these two expressions together in this situation. So because the two y values have different signs, we can just add them. So in this situation, we're going to add them, and then we'll look at another situation where we would subtract them again. So x plus x, that's just going to be 2x, y plus minus y, so y plus negative y. We know that's the same as y take away y, so that's going to equal 0. That becomes plus 0 equals 5 plus 1, that's 6. And sorry, I forgot to just label these two equations. So from that, we're going to see, okay, 2x equals 6, so x equals 3. Fantastic. So what we do is we go back, we plug that value into equation 1. So we go, x is going to equal 3, so 3 plus y, and I'm just going to label equation 1 again here. 3 plus y equals 5, so y equals 2. So again, we're just going to give our answers in coordinate form, as I keep saying we should always do. So x comma y equals 3, because that's the x value, comma 2. Anyway, let's have a look at another equation here. So this one, we're going to see, okay, this is a negative y and this is a negative y. How are we going to either add or subtract these? Would we add or subtract these two values if we want to eliminate the y's? Well, okay. If we added these two values, we could be going minus y plus negative y. That equals negative y, take away y. Well, that would equal minus 2y. So we don't want that. That's wrong. So what could we do instead? Well, what if we subtracted them from one another in the same way as if these were both positive? We subtracted them, so we'd have negative y, take away negative y, and negative, taking away a negative is the same as adding it, so you get minus y plus y, and now it just equals 0, right? So, okay, what we need to do in this situation is we need to subtract them. So what I'm trying to get at here, girls, is a very simple rule that once we have the same coefficients for two of our variables, we decide whether or not we subtract or add those two values based on whether they have the same signs. So if they have different signs, I'm just going to zoom in here and write down a note about this. So different signs, then you add the two, my mistake. So different signs, add, same signs, subtract. I'd even recommend jot that down, circle it 100 times to make sure that you remember this for simultaneous equations. So 2x, take away x, that's just going to be x, minus y, take away negative y, well, that's going to equal 0. And then we've got 7, take away 2, that's going to equal 5. So we have x equals 5. And now we're just solving the rest of the equation the same way that we have been solving each other one. Once we've got x, we take equation 1, and we plug x into that equation. So we get 10 minus y equals 7. Yeah, 10 minus y equals 7. So minus y equals minus 3. So y equals 3. Okay, so let's just pop that into coordinate form there. X comma y equals 5 comma 3. Great, okay. So this is when we don't need to do anything to our coefficients, but we remember from yesterday, we don't always have the same coefficients, do we? So I'd say pause this video, take down these notes, and then I'll move on, okay? Fantastic. Okay, so let's move on. Okay, so we're now looking at some questions where the coefficients of the variables are different. So we'll need to approach this in a slightly different manner, won't we? We'll have to do similar to what we did last time. In our last video, we'll have to multiply the first equation so that we got 2 in front of y in both cases. So multiply that first equation by 2, and we've got 6x plus 2y equals 22. So 3 by 2, 6, y by 2, 2y, 11 by 2, 12, say 22. And then equation 2, we're not going to edit in any way, but we will still plug it in here. And now we're going to look at the signs, okay? So first we multiply so that we have the same coefficients. Then we look at the signs. These have different signs, so we know we just need to add them, don't we? So we add these equations together. So 6x plus x, that's 7x. 2y plus negative 2y, that's 0. And 22 plus negative 1 is 21. So 7x equals 21. So from that, x equals 3. Now, let's have a look at finding y now, okay? So we'll take our first equation again. We'll plug the 3 into the x section here. Plus y equals 11. So 9 plus y equals 11. Y equals 2. So x comma y equals 3 comma 2. Great, so we've got an answer for this there. Fantastic. Now, let's have a quick look at our next equation here, okay? So this one, this one's a bit tough, because now that we're looking at it, the y's are on different sides of the equation, okay? So we're going to need to change equation 2 so that the y's are on the same side, okay? So how would we do that? Well, first, we'll just jot in equation 1 there again. We've got 2x minus 5y equals 3. And for equation 2, we're going to edit that, so we're bringing the 3y over. So we'll end up with x minus 3y equals 1. So just manipulating these equations, nothing more. So if we're given an equation where the variables are on different sides of the equation, we need to bring those variables over. Okay, so what do we do next? Well, we don't have the same coefficients for y. So, okay, this one is negative 5, this one's negative 3. Oh, so what are we going to do? Well, what we're going to do is we're actually going to multiply both equations so that they have the same coefficient. Okay, so we're going to multiply the first equation by 3 and the second equation by 5, because the lowest common multiple of these two equations is 15, isn't it? Of these two values, 5 and 3. The lowest common multiple is 15. So multiply our first equation by 3 and our second equation by 5. Let's have a look at that there. So 2x multiplied by 3, that's going to be 6x. Minus 5 multiplied by 3, that's minus 15y, equals 3 multiplied by 3, that's 9. Now let's look at our second equation. X multiplied by 3, that's 5x. Minus 3 multiplied by 5, that's minus 15y. And 1 multiplied by 5, that's going to be 5. Okay, so now we've got the same coefficient for y. After that, what we need to do is we need to look at these signs and go, okay, they are the same. So, as we know, if they are the same coefficient, we subtract them. So, 6x, take away 5x, that's x. Minus 15, take away negative 15, that's 0. 9 take away 5, that's 4, so x equals 4. Fantastic. Okay, now let's go back to equation 1 again, and we're going to try to find y. Okay, so 2x, and we know that x is 4, so we're going to go 2 multiplied by 4, take away 5y equals 3. So we know that 8 take away 5y equals 3. So we have that minus 5y equals minus 5. So y equals 1. Okay, so just step by step by step by step. Now, we've got x, we've got y. Finally, all we're going to do is we're just going to put into coordinate form. As always, I ask that we put these answers into coordinate form for me. So x is 4, y is 1. Fantastic. Thank you, girls. So I'm going to give you girls some work to give a try at. Can we, on page 195, do questions 2, 8, 11, 17, 20, 23, and 26 for me there. And as always, this will be due tomorrow by 3 p.m. Okay, thank you very much, girls. Have a lovely, lovely day. As always, if you have any questions, feel free to contact me about it.